Here is my response to this question. In this question, it's important to know that this is given. This is the given condition. If this is the condition given, then we have to establish that these three Roman given conditions must also be true. So we have to find out this. Let us work it out. We know that if we have x plus y quantity square, this is equal to if using the FOIL method or any other method, we can expand this parenthesis, and just trying to write it, and the end what we get is this. We get x square plus 2xy plus y square. And they said the given condition says that this thing is x plus y quantity square is given as x square plus y square only. That means this middle term is equal to 0. This is possible only when xy is 0. So this implies that x times y must be equal to 0. So that must be equal to 0. That means the Roman 3 condition or statement must be true to make this statement true. So that is one thing we found, that x times y, the product of x and y, must be equal to 0. So that establishes this fact. Let us work it out, the other one. So again, x minus y quantity square, we are trying to find x minus y quantity square is given as x square, when you expand it, minus 2xy plus y square, which means, and if this thing is equal to x square plus y square only, it means, and we know that x times y is equal to 0 because this is true. So that means x minus y quantity square minus, this one is minus, square is also equal to x square plus y square, minus 2 times 0, because this is 0. So that establishes that this is equal to x square plus y square. So if this is equal to x plus y quantity square equal to x square plus y square, which means that x minus y quantity square must also be equal to x square plus y square. So this is also true. So that is also a true statement. Now I'm going to find the first statement. And the first statement, this one, we know that x y is equal to 0, which means x equal to 0 or y equal to 0, or both of them can be 0. But to make this statement equals to 0, not necessarily that x, the only x has to be 0. Example is this: x times y is 0 even when x, let us say x equal to 1 and y equal to 0, even then x, y equal to 0. So this statement is not a must statement. Example is here: even x, y, the condition is the x times y must be equal to 0. So when x I took as x equal to 1 even and y equal to 0, even then x times y becomes 0. So this one is not a must statement. So going through all the three conditions, the only second, the Roman 2 and Roman 3, they are the must statement. So the answer is going to be E. Now I'm going to also show you the written statement here, or typed statements, for anyone who wants to go through this explanation later. Here is the statement that quantity x plus y square can be expressed as x square plus 2xy plus y square if x is plus y quantity square equal to this which is given, then xy equal to 0, which shows x times y must be 0. And now since this is so it is confirmed that number Roman 3 is a true statement. Since xy is equal to 0, so either x is 0 or y equal to 0 or both. Therefore the statement 3 must be true. But statement 1, which is x equal to 0, is not always true. For statement 2, you can write x minus 2 quantity square equal to x square minus 2xy plus y square. And since xy is 0, it follows that x minus y quantity square is also equal to x square plus y square. Therefore, both statements, Roman 2 and Roman 3, must be true. In here, the y is not written. It says x equal to 0 or, and that one is missed it. So I'm going to write y equal to 0. So I just wanted to complete the statement. I hope you understand the question and its explanation.